Welcome to EECS Academy. Today I would like to talk about the electrical engineering and the computer science major. My name is Dr. Eric Chow. First, let's look at this chart. The electrical engineering and the computer science major is not EE plus CS major. It actually is an integration of the electrical engineering and computer science. So basically, the core course still be the math, and then you still need to use computer science as the modeling language to cover the whole design process of the electrical system and the computer science information system. So the purpose of having this EECS major is to implement the hardware-software co-design. So when a system that involves the hardware component and software component, you can have someone who are good in both sides to manage the program. So from concept, you design the spec, and then divide it into the hardware component and software component, and you build a model for them, and then you work on the hardware-software partition, and then hardware go for hardware design, software go for software design. And you need to set up the test plan, and you can build different kind of devices, including cell phone, drone, a robot, or autopiloting cars. So let's look at the hardware-software co-design from different point of view, from the interpretation level point of view. So basically from software app to subsystem to circuit to device. These are the whole spectrum. I have already discussed this in the EE major. So here, what I would like to focus on is the language that used in different level. So from high level, you may have the website construction software language, such as HTML, CSS, and JavaScript. And then it will touch the back-end database or web pages, such as PHP and SQL, and maybe also Java and Python. And then going down to the lower level, you may have C language and assembly. And it comes the interface between hardware and software. That would be the instruction set architecture. And then below that, that would be circuit. And the circuit can be modeled by Verilog, System C, or VHDL. And then you synthesize it down to the gate level, and gate level will go to the layout or circuit level, and the end of circuit can be simulated by HSpice. And some of the netlist can be described by EDIF. So these are different languages at different level for the hardware-software co-design. And EECS basically is trying to educate some people who can authorize the management of such a team. So here, let's use a very simple model. You can build a mathematical model by Simulink model. This Simulink model can be replaced by Python or different system modeling language. And this is actually a mathematical package. So your math concept will be translated into mathematical model. And that mathematical model will be broken into the microcontroller type block model and the FPGA type model. And microprocessor control block can be done to a DSP core, and this one will actually go for the microprocessor branch or DSP branch. So basically a processor with the software will be the left side. This one is the software model. Right hand side, you can go to the hardware design such as FPGA or ASIC. Then you can use a Verilog or VHDL to actually model it, and then you do synthesis. And from system to Verilog, there is a system synthesis. So basically, this is a very simple model for using microprocessor and the FPGA or ASIC. And these are the engineering flow for the hardware-software co-design. And to be more specific, the processor can be ASIC, FPGA, ASIC, application-specific processor, and then DSP and general-purpose processor. So DSP and general-purpose processor, they are more general and they take programs. And ASIP and these are ASIPs, they are both processors, but they are more specific purpose. And ASIC and FPGA are pure hardwares. So basically, in your electronic system, it is not just the microprocessor or DSP. It can come with one chip with microprocessor DSP and another chip with ASIC, microprocessor DSP, and ASIC, maybe all in one chip. So the final chip layout and final chip format is by design. We really cannot predict what will be put into a chip format. And electrical engineering and the computer science is to realize such a chip system or software and hardware system to fulfill the purpose of the computation system. So from AI point of view, you can have CPU, GPU, TPU, and FPGA. FPGA is dedicated hardware, and CPU is general purpose processor. GPU is graphic processor unit. TPU is tensor processing unit, dedicated for TensorFlow or tensor processing. So these are different processing units that you can use for AI. So here it comes the different design levels for the EE discipline. We won't repeat here. This one is the basic programming skill, core course for computer science, and the application courses for computer science. These are what computer science major will take. So this one we won't go into the detail as well, but basically, in addition to the software and hardware, the EECS student need to also learn the hardware software code design techniques. And the technique come from the mathematical modeling of the system. So basically, the core course for the EECS student that need to take is actually EE system, signal and systems. The circuit and device are optional. And whole computer science core courses and the mathematical modeling courses. In high school, you can take the AP Physics, Hackathon, and Robotics to boost up your knowledge in signal and system. And in core computing courses, you can take APCSA and APCSP courses. And mathematical part, you can take the calculus courses, statistics courses, and other math courses. So here in college, basically college algebra, honor pre-calculus is needed. Then calculus 1, 2, 3, 4, 3 for multivariable, 4 for the differential equation. And then linear algebra and discrete math, and random process, probability, statistics, and data analysis. These are all required for the EECS students. Other courses may be optional. So take the UC Berkeley EECS majors requirement for lower division. And you need to fulfill all of the computer science requirement, CS61 ABC courses series, also EE16 AB series, and CS70 for discrete math. And based on the core courses that fulfill the programming skills and introduction to EE and basic math course 53, 54, 55. Then you need to take the EE courses and computer science courses. So basically, Berkeley's EECS is a all-you-can-eat buffet style, so you need to pick the right courses for yourself so that you are able to handle both from the language point of view and for system point of view. For AI specifically, you need to finish multivariable differential equation, discrete math and probability, random processes, and optimization models. And from EE side, you need to finish signal and system, DSP, robotic 1 and 2, and also computer science, artificial intelligence, and machine learning. And for MIT, it is the courses series 6.2, and that's electrical engineering and computer science. So basically, they have software courses over here, hardware courses over here, and the code design courses over here. Thank you. Bye now.